Hi guys, welcome. My name is Venkatesh Gowda and I'm studying computer science at Sri Venkateshwara College of Engineering. So today's video will be about corrosion. So let's start the video. So let's get into the introduction part. What is corrosion? Corrosion can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. It is basically defined as a natural process that causes the transformation of pure metals into undesirable substances when they react with the substances like water or air. This reaction causes damage and disintegration of the metal, starting from the portion of the metal exposed to the environment and spreading to the entire bulk of the metal. So this is how the corrosion of metals or any particle looks. Now we shall discuss about the dry corrosion. Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reactions. It occurs by direct attack of atmospheric gases such as oxygen, hydrogen, sulfide, halogens, and sulfuric dioxide on the metal, forming the oxide layer. For example, the attack of dry air or oxygen on a metal to form an oxide layer over the surface. So this is how the dry corrosion looks. Now we shall discuss about the wet corrosion. Wet corrosion involves the reactions in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. For example, rusting of iron is an example for wet corrosion. Wet corrosion is explained on the basis of electrochemical theory. So this is how the rusting of iron, which means the example for wet corrosion looks. Now we shall discuss about the electrochemical theory of corrosion by taking iron as an example. According to electrochemical theory, when a metal such as iron is exposed to corrosive environment, following changes occur. A large number of tiny galvanic cells with anodic and cathodic regions are formed. At the anodic region, oxidation reactions takes place and the metal gets converted into its ions, liberating electrons. Consequently, metal undergoes corrosion at the anodic region. At the cathodic region, reduction reaction takes place since the metal cannot be reduced further. Metal atoms at the cathodic region are unaffected by the cathodic reaction. Now we shall discuss about the reaction that takes place in the electrochemical theory. At anode, oxidation takes place in which the metal atoms are converted into their ions, liberating electrons. At cathode, the cathodic reaction is based on the nature of the environment. In the absence of oxygen, in acidic medium, liberation of hydrogen takes place. In neutral or alkalic medium, hydroxide ions are formed with simultaneous liberation of hydrogen. In presence of oxygen, absorption of oxygen takes place. In neutral or alkaline medium, hydroxide ions are formed. Then iron ions Fe2 plus form anode combine with hydroxyl ions from cathode to form iron hydroxide on the surface between the anode and cathode areas. Iron hydroxide further reacts with oxygen and water forming hydrated iron oxide, which is the corrosion product, which means rust. So we can look to the reactions which takes place. Now we shall discuss about the types of corrosions. First is the differential metal corrosion. Differential metal corrosions occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as the anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode, and it undergoes reduction and gets protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. The reactions may represented as anode. M gets as M plus N electron. At cathode, reduction reaction takes place depending upon the nature of the environment. So we can look at the reactions. Now we shall discuss about the differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of the metal exposed to a lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. For example, iron rod partially immersed in NaCl solution is part of the metal immersed in solution and it is exposed to a lower concentration of oxygen and it becomes anodic and it undergoes corrosion. Whereas part of the metal outside the NaCl solution is exposed to more oxygen, becomes cathodic, and it remains unaffected. So this is how the differential aeration corrosion looks. And we can look at the reactions. And the other examples of the corrosions are part of the nail inside the wall undergoes corrosion. Second is when a dust particle sits on a metal bar, the part under the dust undergoes corrosion. Third is partially filled iron tank undergoes corrosion inside water. I hope the video was informative. Thank you.